Welcome to Brain Vision.
All right. In this problem, a lab technician, clumsy as he is, drops a small object of some unknown substance with an initial temperature of 100 degrees Celsius into a calorimeter, made out of copper and containing some water. The initial temperature of the calorimeter was 19 degrees Celsius. The final temperature of the whole system is 26.1 degrees Celsius. And the mass and the heat capacity of these things are listed here. The mass of the unknown object is measured to be 0.085 kilograms. And we wish to find the heat capacity of the unknown substance, which I denoted as S. You can easily see that since the unknown substance has a higher initial temperature than the initial temperature of the calorimeter and the water, then the calorimeter and the water will absorb heat from the substance, and the substance will obviously give out heat. So we can set up a heat exchange equation. On one side of the equation, we're going to have the heat the heat absorbed by the calorimeter and the water. So we will have M copper, mass of the copper times the heat capacity of copper times delta T, delta T1. And and to avoid the complications that can arise from the signs, I'm just going to take the absolute value of that. Plus mass of water times the heat capacity of water times also delta T1. This is going to be equal to the mass of the substance times the heat capacity of the substance multiplied by delta T2, like that. And so we wish to find the heat capacity of substance. So we simply rearrange this equation, dividing both sides by ms times delta T2. And so we will get the heat capacity of the substance is given by mass copper times C copper times plus mass of water times C water times delta T1 in absolute value sign divided by mass of the substance times absolute value of delta T2. And so we see that, delta T1 will be equal to 26.1 minus 19. I should have degrees Celsius here. And so that amounts to 7.1 degrees Celsius. And delta T2 is equal to 26.1 minus 100. And this is equal to negative 73.9 degrees Celsius. And so then the absolute value of this thing is equal to the absolute value of that, And so we will get positive 73.9 degrees Celsius. And so you just, shove all these numbers in here. I suppose this should go in here, and this number should go in here, and all of these numbers can go on the top and on the bottom. And if you do that, if you plug in all these numbers, you will get the heat capacity of the unknown substance is roughly 1.01 times 10 to the third joule per kilogram K. So that's the answer to this problem.